Hi and welcome to Redeye. With me today I have Daniel Gidlund, CEO of Freemelt. Welcome, Daniel.
Thank you, Anton.
And to start off, you recently released your Q2 report, and as usual, how would you like to summarize the quarter?
I would say that the quarter we had high activity, both on the commercial side, but also on the technical side, the development side. I think we made good progress when it comes to our industrial offering Freemelt, both on the commercial, but also an industrial side here, where I think we really had two key milestones. The first one was also now that we got the first machine order into the US, which is a key market for us. And also during the quarter, we finalized the readiness of our first shipment to our first customer in Italy as well. I think during the quarter as well, we also re-emphasized our position. We talked about it a couple of times when it comes to tungsten, that we have a leading position, but also in fusion application. I think UKAEA, so the UK Atomic Energy Authorities, which is leading this work in the UK, we now stepped into our phase 2 development with them on tungsten components for fusion applications. We also had, actually from a North American customer, which is not named, we also got a feasibility study as well, also for fusion. So tungsten and fusion, I think, maintain to be really in focus. Where we have seen, and I think in the quarter we could see a further, let's say, increase in demand, that is in defense. So here, both we got one machine order from the University of North Texas, which will focus on defense applications. And then we also, actually after the quarter, we also got another feasibility study for defense application. And then last but not least, I think now when we see this increased demand as well from potential industrial clients, the 5 machines that we have here in Mölndal are fully occupied now with work, which is great. But we of course would like to continue to take on even new demand, while we also now strategically search for collaborations. And here we also signed up with some really strong and interesting collaborations during the quarter. So all in all, very high activity both on the commercial but also on the industrial side.
And if we look at the financials, at first glance, it may look like they had a challenging quarter with sales declining 56% year over year. Can you elaborate on the quarter's sales development?
Yeah, I mean, every quarter is a challenge when you're trying to educate and disrupt the market like we are. No, jokes aside, I mean, I think our sales team is making great progress now in our efforts to educate the market about the additive manufacturing, Freemelt, our technology, and then also our machines. And we can see now, I mean, the industrial interest is driving new demand, as I mentioned before as well. Why these type of feasibility studies also now start to increase as from customers. And I think this is also just to highlight, we talk a lot about tungsten, but this is actually for all our focus materials: titanium, copper, and tungsten. When it comes to the academia side, this customer segment, it's a very transactional business. And this is why we also then see big variations between quarters. The positive side, at least, is that we see an increase in order backlog. But due to some unfortunates, we couldn't finalize all the deliveries that we were aiming to close during the quarter. And just to explain as well, most of the time, these type of delays are actually caused by the customer, because the customer must prepare their facility to fit the purpose to have an electron powder bed fusion machine there. And we will never complete an installation because of safety reasons before everything is in order. And this was actually what caused this delay for this quarter.
And if we take a step down in the P&L, we also saw a sequentially increase in costs, which surprised us a bit. What drove costs in the quarter, and how should we think about the cost structure going forward?
Yeah, no, I think I can understand your reaction, and I think we also did indicate in the past as well that we, especially on the development side of where we use external resources like consultants, etc., that part should taper off when we're now launching the machine as well. But what we actually decided to do was to ramp up investments, especially in the US and especially then in the organization there, because we see such a rapidly increasing demand in the US, especially for tungsten and then the various kind of applications. So at least here we expect to see some good return on investment soon as well. The other main cost driver was consultancy cost, and especially in technology consultancies, as we just had to really step up and finalize the development prior to the shipment of the machine as well, going to Italy. So it was mainly then driven by software, but also some other technology development that was required. So, but I would say, I mean, now we have delivered the machine. We are on top of our cost. So I think the cost levels should also come down moving forward as well.
And if we go back to the operational development, as you mentioned, you have signed several new agreements. Which ones are you most excited about?
Yes, a good question. I think, first of all, I mean, this is in line with our strategy to collaborate with partners as well, so we can accelerate the education of the industry clients. But also then that we can enable to meet the increased demand as well of the feasibilities that I mentioned a couple of times. I don't think it's possible maybe to say which one is most exciting. I mean, we only try to get into strategic and exciting collaborations. But as we focus a lot on tungsten, I would say it's extra fun and also valuable with the collaboration with Sandvik, who supplies tungsten powders. And also then the combination with the Mid University that has extremely high EPBF knowledge, so electron powder bed fusion knowledge, which is crucial. So here we are really excited to see what we can do together to certify the Sandvik powder to the Freemelt machines. And I think it may be good to understand that the powder of the total cost to print the part, powder represents roughly 50% of the cost. So it is critical to develop processes for chemical reduced powder like Sandvik has, which then will substantially reduce also the cost for the powder and for the customer to print the part.
And in the report, you also write that it typically takes several months for a company to transition from traditional manufacturing to 3D printing, and that it often starts with material process studies, which you have several of. And now that you have several projects ongoing, can you provide some insights into the projects that are approaching the end phase?
Yeah, that's correct, Anton. And to be clear, I mean, it varies between projects of the time required, and depending also, I would say, on the customer maturity and the readiness, but also the material and the complexity of the application. But I mean, to answer your question, all of our machines that we have here in-house in Mölndal, they are allocated for customer projects, and even some of our customer machines used for, I mean, our customers' machines. So we have sold Freemelt ones. So we even utilize some of them as well for customer projects. So a lot of ongoing customer projects, as you correctly said. And this is also across the different kind of materials. Having that said, I mean, we have only actually started to publish these type of projects and feasibility studies recently. Why I unfortunately cannot comment on on all of them, but I can comment on the ones that we have press released. Then Saab is one of them, and I would say that in Saab, we are progressing well, and we are currently in material testing. So the build of the parts has been completed, and now it's in testing phase. So let's see where that goes. Hopefully, it will be a continuation to the next phase of that project. The other one that we have press released as well, and we have repeated many times, is UK AEA. And here we are already in the phase 2. So here now it's more about the productivity, and now it's more complexity of the parts, etc. Here, I would say it's also progressing really well. But we still have a few months to go before that phase 2 will be ready as well. And then we have actually already progressed well in both of the US feasibility studies that we shared also now in the quarter report as well. And we almost complete with phase 1. So yeah, I think that's what I can say. Maybe what I can say as well, I mean, we also have been in a few ongoing ones as well for approximately 12 to 15 months as well, which we have not press released. But here I think I can also say that we're in development as well.
Okay, so we have to wait and see.
Unfortunately.
Yeah. And I mean, you continue to highlight the different growth initiatives within the sectors that you hope to be a part of, where universities and research facilities play a vital role. I mean, how do you target these, and how does the competition look like in terms of signing agreement with these universities and research facilities?
Yes. I think how we target this is traditional market intelligence. I mean, that's how we identify these ones. We now, if I take in the US, for instance, I mean, we have also recruited a very experienced team. So, of course, also through network and personal relationships and so forth. We try to also, in the past, we have spent a lot of time being in additive manufacturing trade fairs. What we try to do now is to move more into industrial specific trade fairs, to really be present and to first identify the potential customers, but also to make ourselves aware at those trade fairs. And then I think, especially I think what we have seen in tungsten and fusion, reference cases. I think now this is also the important part to share what we do, and because that really attracts that to bring up interest from other potential interested parties as well. And I think especially when it comes to tungsten, which is such a complex material, which just a few has considered in the past as well, that you can actually manufacturing parts with. When they now start to see that this is possible, this actually brings a lot of new prospects to us as well.
And how will you say the competition is? I mean, what are your primary competitors in terms of targeting these universities? And
of course, I think if you take a university as such, most universities, I mean, they use additive manufacturing. So here, I mean, they do in all different kind of materials, in plastic and metal and so forth. So here, it's a range of competition. If we zoom it down more on refractories, such as tungsten, more complex materials, then I think the competition is much less as well. And then I think what you need to add to the complexity as well is a type of application. If it's really an application where material is critical, then you just have the even less left working with electron powder bed fusion, because that's where you need to have a vacuum chamber, you need to get up into temperature. So here I would say the competition is even lower. And I think here we have a very strong position, especially when it comes to the refractory metals as well.
And I mean, given that the end market can be enormous in these sectors, are you seeing that there are any more players entering the space, or yeah?
I think the positive side is, if we take a step back, I mean, electron particle fusion, it was pretty much in monopoly with Arcam, so another Swedish company that was acquired by GE 2017. So then it was one, and at this moment we are nine. So definitely we can see an increase in interest for these type of applications. Then having that said, if you would compared to a laser 3D printer, I mean, that's a much more simple process, which why there are like 60, 70 different kind of suppliers. But when it comes to electron particle fusion, it's more physics, science, etc., more difficult to really get it to work in a proper way. And that's why it takes a bit more time for new players to enter this market as well. So here we definitely, I mean, we are the clear runner-up after GE, which is the leader here. But thanks to the founders of this of Freemelt and all the experience they have from EPBF, we have had a short starting track and to take us to where we are at this moment.
And lastly, is there anything else you would like to add?
Yeah, I think what is pleasing to see now is that, you know, our dedicated and also persistent efforts in educating the market. I talked a lot about you need to educate the market to really understand, you know, why additive manufacturing, why our technology. Now we start to see that it start to materializing into demand of these feasibility studies and also for application development. And this is from potential industrial serial producing applications. And I think also just to remind everyone as well that, you know, this is a global industrial transformation or maybe even a revolution that additive manufacturing has started. And, you know, to really make a transformation or a revolution, it requires change, and change is typically is something that is difficult if you have something that is working okay-ish that you have worked with for many years as well. So in that regard, I think it's positive now with the geopolitical situation that we have. I wouldn't say that is a crisis, but at least there is now much more push from the industry as well on new, more innovative manufacturing technologies, and especially if you go down to energy applications or defense applications, then the push is even harder. So now we don't have to push and try to convince. Now actually we also get the request from the industry to help them to become more innovative. So that's really promising, and I think we have a very strong position in especially those two applications as well.
Good. So that was my final question. So thank you very much, Daniel.
Thanks, Anton.